talk about independent events today and organizing our outcomes. Independent events are events that do not impact each other. So for example, spinning a spinner and flipping a coin do not impact each other. If I flip a coin and get heads, it does not impact when I spin a spinner and get 1, 2, 3, or 4. Same thing if I roll a 6-sided die. Rolling a 6 does not impact if I get heads or tails when I flip a coin. So those are independent events, meaning they do not impact each other. Okay, so we want to be able to organize our events. So far we've only had one event, and so we're flipping a coin or we're rolling a die, whatever it is. Now we're going to start combining things. So we want to be able to organize the possible outcomes in a uniform way. Okay, so we're going to do that. I'm going to show you 3 different ways. First, let's use this for an example. We're going to have a toonie. Okay, possible outcomes with a toonie. Heads or tails. Okay, heads or tails. Hopefully we can see that what I'm putting there. Heads or tails are our possible outcomes. And then we have a die. Okay, we have 1, 2, 3, 4, 5, and 6 are possible outcomes. Now we're going to do these 2 events together, and we'll see the possible combinations. So if I have a toonie and a die, my possible combinations when I combine those, I could have heads and 1. So here we have all the possible combinations. Okay, heads and 1 through 6, tails and 1 through 6. So we have 12 possible outcomes or 12 possible combinations. So this here, when we write it this way in brackets, looks very similar to coordinates for the Cartesian plane, ordered pairs. Okay, very similar. Okay, we call this a sample space. Okay, so a lot of times they'll be asked to list a sample space for an experiment, and this is what you would do. List all the possible outcomes in brackets. Okay, another way we can do this, listing these possible outcomes. We could also do what's called a tree diagram. Tree diagram. Okay, so tree diagram is going to contain all the possible outcomes. So in a tree diagram, the first event, I always like to do on this one, the event that has the fewest outcomes. So with the toonie, we have heads and we have tails. I space it out there a little bit. You'll notice why in a second here. Second event is going to be our die. And here we have possible outcomes for the die are 1, 2, 3, 4, 5, and 6. Okay, so in combination with heads, we can have heads and a 1, heads and 2, heads 3, heads 4, 5, and 6. Now the important part here noticing is that is one set of combinations used with the heads, and then this could occur. When we flip a tails, it is also possible to have 1 through 6 occur here, so we have to list those again. Now you'll notice this is called a tree diagram because of all these little branches that are created here. So these branches show all the outcomes. And then our last column is the outcomes, and we will list. So here we have all the possible outcomes listed. H1 through H6, T1 through T6. Okay? First event, second event, all the possible outcomes. That's a tree diagram. The third and final way we'll show you is using a table. Okay, a table is going to be the 2 combined events. So we're going to draw a table. Again, on this one, I like to put the event with the fewest, so I'm going to put the toonie here. Okay, and again, our possible things with a toonie are heads and tails. Okay, and up here is going to be the die. So event 1, event 2, event 1, event 2, doesn't matter which way you do it. So with the die, we can have 1, 2, 3, 4, 5, and 6. So now I can make so there's our possible outcomes for the die, possible outcomes for the toonie. Now I can. Here we have all the possible combinations of flipping a toonie and rolling a die in a table. Again, along the top you have the outcomes possible for the die for the one event. Down the side you have the possible outcomes for the other event, and then in the middle of it you have all of the possible combinations or the possible outcomes for this event.
Okay, I'm going to show you a couple of questions here. I'll do a couple for you, and then I'll assign a couple of those for you, just so you can see exactly what we're looking for, what we want to show with questions like probability questions like this, organizing our outcomes. Okay, for number 5, Clarice flips a disc that is black on one side and white on the other side. Then she chooses one card from 5 cards shown here. Organize the outcomes of these 2 events in a table. All right, we're going to take a table. So again, the 2 items are, the first one is she's flipping this disc, so it's like flipping a coin. One side is white, one side's black. And then she picks from these cards. So she would flip and then pick a card. Okay, these are 2 independent events. When she flips this disc, it does not impact what card she picks. When she picks a card, it doesn't impact that. So these are independent events. So if I'm going to make a table, again, I like to do it with the one with the most along the top. So the second one is going to be the cards. Okay, and listing the cards here, we're going to have moon, and then we're going to have sun, cloud, star, rainbow. Okay, the second one is going to go, oh, it's a beautiful straight line right there. Second one is going to go down the side is disc. What are the 2 possible things? We have a white side and we have a black side. All right, there's my table. Now we just have to fill in all of the possible combinations. So we can have a white and a moon, white and a sun, white and a cloud, white star, white rainbow, black moon, black sun, black cloud, black. Oh, here we had an example and I almost missed it. So a star, we're going to put ST. So it differentiates between white and sun, white and star, black and rainbow. Okay, so there is a table completed, organizing all of the events. Here are the possible outcomes. Part B says, can't see it. Part B says, what is the sample space for this experiment? Now this is where some laziness, we've got to be careful here. Kick this in. Part B, when we have the sample space, they're listed in brackets. So again, you're going to take all these possible outcomes and you're going to list them. WS, WC, WST, WR, BM, BS, that's a good one, BC, BST, and BR. There's my sample space. Done. Now we're going to do number, how about number 8? Because it wants a tree diagram, just to show you the 2 of them. Georgina spins a spinner with 4 equal sections as shown. 1, 2, 3, 4. Rolls a 4-sided die labeled 1, 2, 3, 4. Use a tree diagram to show all the possible combinations. Okay, again, on this one, usually I do the one with the fewest first, but this one that's the same amount, so it doesn't matter. So we'll do the first event. We'll do a spinner. Event 2. Second event. Die. And then your outcomes. So the first one is going to be 1, and then 2, 3, and 4. I'm running out of paper here because this one takes a lot of room. Second event, so this one has 1, 2, 3, 4. Here's a common error that we have coming in here. Remember, this event is independent of this event. So when I spin a 1, all of these are possible in combination with that. When I spin a 2, again, all of these are possible again. So we have to repeat those again because all of those are possible. After I spin a 2, I can still roll a 1, 2, 3, 4. When I spin a 3, yes, I can still roll 1 through 4, and the same goes down here. Okay, you can see how these number possible outcomes add up. So now I will put my branches. 1, there, I have all my branches made. Now I have to list all the outcomes. So we could have a 1 and a 1.
Have a 1 and a 2, a 1 and a 3.
Didn't have enough space, should have started higher right there. So now we have all of our possible outcomes listed there. In the next, we're calling to determine the sums of the two outcomes. Now you're going to see these once in a while, so I may as well demonstrate this. So this is fairly simple. Sum means addition. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. What is the most common sum? So now you're going to look down here and see which one occurs the most. My guess is it's going to be 5 is in all of these. Okay, where 4 is only in 3 of them. 3 is only in 2 of them. 2 is only in 1, and 6 is only in 3. 7 is only in 2, and 8 is only in 1. So for part C, the most common sum is 5. It's in all of them. Okay, you're going to do questions 4 and 6. So this one is a table. Then you're going to list the sample space. Then you're going to tell me why it's independent or not. This one you're going to do a tree diagram. Okay, read carefully what it has for you. And then you're going to list the sample space. Okay, page 169, 4 and 6.